Bismillahirrahmanirrahim. Welcome to the next part of our series of videos on virtualization. Now we are going to cover the XEN architecture a bit, not in full detail because it would be too difficult for many of the viewers to digest it at this moment. I'll just cover main things. Few of the things we have already covered in the previous 3 sessions. I'll just cover them briefly. We already know now that XEN Hypervisor runs directly on machine's hardware, and the kernel is loaded as module by grub bootloader, which I've shown you through the this machine's configuration, that when this is loaded, this is the title in fact, when this XEN is loaded as a kernel and this is loaded as a module, and again this is a XEN aware kernel. Fine, so exit this and go back here. Okay, so when grub boots, it loads this kernel XEN, and the hypervisor, which is kernel XEN, creates the XEN domain, initial XEN domain or domain 0, and then domain 0 then boots up. Domain 0 has full privileges, which I mentioned earlier, and it is used to control both the XEN hypervisor and the virtual machines, other user virtual machines or guest virtual machines. XEND or XEN daemon is a program which we use from domain 0 to control XEN hypervisor start, stop, and various other functions. XEN provides this kind of security structure as well, that the domain 0 is in one security domain, and the virtual machines are in the other security domain. It's crucial to understand that if domain 0 is compromised through some manner, then the virtual machines can also be compromised, because domain 0 is being used to control them and access them, and various other related things. It's also important to note that one domain U or user domain cannot access other domain U directly. It cannot even access the other domain U indirectly, because for a domain U or for a virtual machine, it's just a standalone virtual machine, and any other virtual machine can only be accessed through the network interface or the network connectivity, if there is any. Otherwise, there is no direct access to other domain U from one domain U. Only domain 0 can access all of the domains or all of the virtual machines. If you have ever used, if you have used this Red Hat Enterprise 4 or before, then starting in Red Hat 4.5, we had this kernel XEN U as the kernel which used to boot up instead of kernel XEN. In Red Hat 5.0 and onwards, we are now having a simpler kernel XEN naming scheme, which boots up both in domain 0 and in domain U or guest domain. It's also important to know that Red Hat 4 cannot be used as domain 0, and Fedora 4 to Fedora 8 have this facility to act as XEN domain 0. However, after Fedora 8, that is starting from 9 and I know 12 till now, they don't have facility to run as XEN domain 0. They do have facility to run as domain U, means you can have a virtual machine running a Fedora 9 or Fedora 8 or Fedora 12, even Fedora 8, Fedora 4, whatever. But in favor of KVM, kernel-based virtualization, Fedora dropped XEN's domain 0 support. It's also scheduled to be dropped from Red Hat, and it's really funny that once Red Hat 5 came out, Red Hat was jumping 10 feet high in the air that Xen is the best, Xen to be used, Xen is the ultimate virtualization solution. And the moment they acquired KVM, they just dropped it as a used tissue paper and started boasting KVM that, oh, KVM is the best. And that means, like, for the customers that they have to turn 180 degrees and switch to another technology. So Red Hat came under heavy criticism for that, and they announced that they will support Xen for next 5 years. So this announcement was made probably like 8 months ago, as far as I remember correctly. So we still have 4 more years to go, and we'll still enjoy 4 more years of Xen with Red Hat. That will automatically mean that we have 4 more years at least with CentOS, Xen on CentOS, because KVM is by default included. I've mentioned it in this document elsewhere, that KVM is now part of the kernel starting from 2.6.20. And let's see what version we have here. We have 2.6.18. So this version, this should have KVM, but it's part of somebody. I read it somewhere in KVM documentation. It's part of all the kernels from 2.6.20 onwards, or maybe I'm not remembering the correct figure or the version number. Anyway, let's come back to the point here. Fedora 4.2.8 can be used as domain 0, as Xen domain 0, but Fedora 9 to 12 inclusive cannot be used as domain 0. And all versions, I just mentioned a moment ago, all versions of Fedora can be used as guest domains or domain use. Full virtualized, if you have got fully virtualized hardware, it can use the fully virtual machines or the guest machines. They must use normal kernel instead of kernel Xen if you are going to use the full virtualization mechanism. Xen supports both methods. You can have simultaneously virtual machines running as paravirtual, and at the same time few machines running as fully hardware assisted virtual machines running on the same physical host at the same time, provided you've got the hardware extensions in the CPU, to be short. Okay, so we'll briefly go over this privileged ring architecture. In almost all the modern day processors, we have this security architecture built in. It's not particular to Xen. We have compartmentalization, or we have this so-called security rings, ring 0, ring 1, ring 2, ring 3, ring 0 being in the center and expanding outwards. So ring 0 is the core, and ring 1, 2, 3 are the outer edges of these rings or circle. So kernel Xen runs in domain in the ring 0, and the virtual machines or guest machines, they run in the low privilege, higher number but low privilege rings. Again, ring 0 is highest privilege and ring 3 is the lowest privilege. So the higher the number, the lower the privilege is. So that's how the ring architecture is defined in Xen. In a normal Linux environment, you would have a Linux kernel running in ring 0 and the rest of the utilities running in other parts of the rings, or run particularly in ring 3. And ring 1 and 2 are normally not used. However, in paravirtualization, there's the domain 0. It runs in the higher privilege, and domain use, they run in the lower privilege. There are further complication in 32-bit and 64-bit, or the difference. There is further difference between the 32-bit machines and 64-bit machines, such as in 32-bit machines or architectures, domain 0 and domain U kernels run in ring 1, and kernel XEN itself runs in ring 0. On 64-bit architectures, this segmentation is not supported. So kernel space and user space for virtual domains both run in ring 3. That is for virtual domains. Alright, so what else? Let's talk about very brief. I'll cover this later at a later stage as well, once it's the right time, because this is probably complicated for many of the viewers at the moment, and I am planning to jump to the much anticipated action now. I'll very briefly cover this XEN networking concepts. Basically, XEN supports two types of networks, two types of virtual networks, if I must say. One is shared physical device and one is virtual network. When you set up a virtual machine inside XEN host, it can be connected to this XEN host or the network through shared physical device. That means the virtual machine and the physical machine's network card, they share the same network. Means if XEN host is physically on let's say 10.1.0.0 network, and it has an IP of 10.1.0.1, then when you create this virtual machine inside it on shared physical device, it will acquire an IP on 10.1.0.2, means on the same network, through some DHCP, or if you configure it manually. That way this virtual machine will be on the same network and will then be accessible through the external network again. However, this virtual network or virtual bridge 0, this is a private, so-called private switch inside your XEN host. When you create a virtual machine and you assign its network card to virtual network, then it gets an IP address of 192.168.122.0, something like that. If I have it here, yeah, I have it here. This IP of this scheme. This is the network of that virtual switch, private switch, which you will have inside your XEN host. This will be an IP assigned to the XEN host itself, the part of this XEN host connecting to virtual bridge, and all the virtual machines which you create and assign to virtual network, they will get connected here and they will get an IP like this one. In this way, the hosts or the machines outside this XEN host on the physical network outside this XEN host will not be able to reach these virtual machines directly. And if these virtual machines inside this XEN host need to go outside, or they need to access the outside world, they would need to be translated or natted. So their traffic would be passed through this NAT device, or there's a special NAT device within XEN virtual device which will convert this traffic to an IP address of the XEN's physical interface, or the XEN's network interface connected to the physical network. This kind of setup is best for your own private lab. Let's say you are in the office and you have very strict network policies, and you cannot have an unassigned host or unaccounted host coming online on the network and interacting with other PCs. but still you want to experiment a couple of things almost daily. So what you can do is create your virtual machines and then just simply connect them to the internal virtual private switch, and they will have their own IP. Their DHCP would be an internal DHCP served through XEN, etc. And they'll have perfect connectivity with your physical host, whether it's a laptop or a PC or whatever, and they'll create no problem whatsoever on your network. So this will be like a sandbox kind of environment. And naturally, if this is the case, then you can't access these virtual machines from the external network using simple methods. There are methods which I'll explain later, through which you can redirect or DNAT the traffic and redirect them inside to a particular virtual host, etc. So this is what very basic XEN network concept is. It has got two network models inside: shared physical device, XEN bridge, and virtual network device, which is virtual bridge. And I believe that from this point onwards, much of this, whatever is explained here, will not make sense unless I first show you some so-called real action. So let's move on. Let's skip this whole part and let's do this. This is good stuff. This is a checklist before we actually start our machines and start creating this virtual machines and all that. Let's see what this checklist says. Make sure that physical address extension is supported. Fine, this is the bare minimum requirement if you want to run XEN. The lowest mode is para virtualization mode, of course, but you've got to have this PAE, and since all modern day processors, with very few exceptions, have this support, so we'll assume that this is served. However, I showed you here that my processor, on which I'm going to create a couple of machines for you, it has this PAE support in the flags section here in proc CPU info. Then make sure you have enough processor or processing power. Yes, we have. I believe we have 3 gigahertz Pentium processor. Should be enough. 2 MB of L2 cache. It should be good enough. Okay, then at least 512 MB RAM for each domain, including domain 0 and domain use. So let's see how much RAM I have on this PC. head/proc/meminfo. Okay, I've got around 1.3 GB of RAM on this PC. I've got more RAM, I believe, on the other two PCs I have, but this should be enough. Enough space in the active partition of the OS for each virtual machine you're going to create. And this is the location where we are going to create virtual machines. Let's see how much space I have on this physical host. So as you might see that, as you might have been noticing, that now we are slowly switching towards this real action stuff. Okay, I have this 20 GB partition, and I have only 6 GB available on it. I have this about 120 giga partition named /data, and I have about 100 gigabytes of free space on it. Lovely. So I can even create a virtual machine here, and as I showed you the path, various lib XEN images, I already might have a couple of machines here, various lib XEN images. Okay, I have this vServer. I have this, I don't know, this rack one. I was experimenting with this Oracle. So I can delete this. To delete this, I need to also delete its configuration file. Alright, we can also create virtual disks on LVMs, SAN, etc. We can also create disks, not disks, why I'm saying disk. I can create, virtual disks. So we can create virtual disks for virtual machines even on raw partitions, which I'll show you how to do it. And of course we'll use Linux, Red Hat Enterprise or CentOS. I'll use Fedora as domain U probably, and in some cases I'll show you once we'll be covering KVM, then I'll show you Fedora being used as KVM physical host. Okay, X interface is needed if you want to run this virtual manager, which I've shown you already. This is the virtual machine manager. Okay, then I need to have this package installed, virtualization. So what I do normally is, on such kinds of hosts, I use a bare minimum installation, such as, I'll show you, probably it's here. I use a Kickstart normally, various HTML. If you don't know what a Kickstart is, never mind, no problem. I just want to show you that what packages. Okay, as you see, I just use the core package and remove all these things which I don't need, and that's all. So whenever I install such kind of a physical host, I try to be as minimum as possible in respect of packages, and add a virtualization group through yum. I'll show you, I've already done so. I'll just show you history, pipes through grep, virtualize. There's a group named virtualization. This is enough, no? Grep yum. Okay, where is that? This is storage, and this should show here somewhere. Interesting. Maybe I've done it on another PC. Let's try connecting to root at 168.168.1.21. This is my Xen host. Probably this is the one. Yeah, this is Xen host 1. This is the one I'm talking about. Probably history, pipes through grep yum, and see here I use this yum group install virtualization. Remember, once you install just core, even yum will not install. So it would be wise to select yum utilities at least. Otherwise, you have to go through all this installing of yum as well before you actually go ahead and install virtualization. This is what I've already done for you on this physical host, Xen host 1. This has interesting hard drive schema. How is it interesting? Okay, let me define. This host, Xen host 1, has got 80 GB of hard drive. But out of that, I've only used about 2.4 GB disk as root, and which has still got about 1 GB of disk remaining. And naturally, I can't fit in a virtual machine inside this much of space. So I'll use the rest of about 77 gigabytes of this PC or machine, and create some partitions, raw partitions, and maybe LVM, and I'll show you how virtual machines and virtual disks, their respective virtual disks can be created. I'll also show you how can we link various lib XEN images to a newly created larger partition where we would create our virtual machines. This is very interesting stuff. We just have to wait a little for that. Okay, so install virtualization package. We've already done that. Make sure we have kernel XEN, libvirt, and virt manager are installed. So let's confirm that these are installed. Yum rpm minus q, or let's okay, rpm minus qa pipes through egrep. Okay, what else? What all we need here? Okay, we need kernel XEN or XEN or so libvirt and virt manager. Okay, so we've got kernel XEN, a couple of versions installed. You see these multiple versions because I frequently update through yum this machine. We've got this XenLibs 3.0. Kernel XEN, we have this. Oh, we already have kernel XEN 164.15. libvirt, we have kernel XEN devel, which is older version. Let's sort this so it's easier to understand. Okay, so we have kernel XEN, this one should be the latest. We have kernel XEN devel, this one is the latest, matching this one, although we don't need this, but I did need this when I was installing iSCSI target on one of the virtual machine, making it as a IP SAN or iSCSI server. So I needed this for. Okay, we've got libvirt, we've got virtual manager, we've got XEN 3.0. Remember, currently XEN is probably at 3.3. Let's see, xen.org. Oh, come on, what's wrong with my typing today? xen.org. Okay, while we wait for it to appear, and we have made sure that we have all these things available. Default boot kernel is the one that starts with kernel XEN. Okay, that's important, so let's check that in storage. I've already shown this to you many times now. Default is the title number 1. Now this is title 0 and this is title number 1, so definitely this is my kernel XEN machine kernel. Okay, so now default kernel in sysconfig kernel. This is not needed, in fact. Let's see what my this file says. etc syscontrol kernel. Okay, let's check what this file says. Although I've never encountered this before, but anyway. Okay, so this shows that kernel XEN is the default kernel. Great. And SE Linux. Okay, this is very painful for many, including myself. Most of the time, the first step I ever do on a physical server is like disable SE Linux, because I come across so many of different problems. But that does not mean that XEN or KVM does not work with SE Linux. They do, and they've got full compatibility with SE Linux. So it's not a wise idea to just drop SE Linux. Since I Most of the time I just provide training or such stuff, so I just make it out of the way for the students to work easily with the core concepts first, instead of getting entangled with SE Linux. On any production server which you might be putting on the internet, I would highly recommend to use SE Linux. Okay, and then lastly, make sure ZenD and libvirtuald services are set to on boot up. Okay, now we pause here for this point. Okay, let's check that as well. We not pause here. Check config, ZenD on, libvirtuald on. So what we can do is we can check config level, not level, let's check list, pipes through grep 3 : on, pipes through egrep, come on, ZenD and libvirtuald. So ZenD and libvirtuald. Okay, let's see. Oh, they're not on. That means they're not on. Okay, so are they off? Yeah. libvirtuald is off, ZenD is off, ZenDomains is off. We don't need ZenDomains at this moment. The purpose of ZenDomains, or function of ZenDomains, is to start certain virtual machines automatically at the physical host reboot. So we're not concerned about it at the moment. We're concerned about these two. And since these two are off, let's check their status. Service ZenD status is stopped. Service libvirtuald status is also stopped. And that is exactly the reason why my virtual machine manager could not connect, giving this error. Zen host, make sure Zen host was booted and Zen service has been started, and this is exactly the case. Unable to open connection to hypervisor this Zen / blah blah, connection refused. Once we start the service, we'll not get this error anymore. So what I'll do is I'll just close this at the moment and go back here, and of course disable all stupid services like Bluetooth, SendMail, unnecessary cups, etc. Everything, just disable everything. Ideally, when I start off with any of the server anywhere, it's not restricted to virtualization, I first of all go back to minimum service, which is SSH. So from there onward, I build up my services, start HTTP, or if not required, don't touch it. I've got this VNC server running on it, through which we are creating this video as well, and X11. This is part of Zen. Some part of these services are started through Zen normally. Okay, but we don't have cups and SendMail running on it. Okay, and we need an expanded exploded tree of your ISO. This is important. Many people think that just placing an ISO here like this one would save them from all worries and will help magically. No. If you are going to use para-virtualization, then remember, para-virtualization, you don't have any hardware emulation, so the virtual machine would not know if there is a CD-ROM drive, and naturally it will not boot. So and also there is no so-called BIOS, so it will not boot in a normal routine. So you can't just put in this ISO file and expect Zen to honor that. No. You've got to explode this into a hierarchy, directory structure here, which I've already done for you, and you see that all this CD or ISO is exploded here. And in fact, this is what we have exported through HTTP conf .d CentOS. Okay, CentOS.conf here. Location data CD images, this one, and allow from all options indexes. How this will help? This is important, this is crucial. If you don't expand your CD here in data images, I would advise you, if you want to keep things simpler, to expand it into various WWHTML here. Here you can explode your ISO image here in that directory here. That way you don't have to create this special Apache configuration file explaining location or directory aliases, etc. to Apache, because Apache by default starts picking its files from this document root. So it's advised to put it here if you are just experimenting and don't want to have so many extra parameters or variables hindering in your work. Okay, I've got this exploded here, and I'll just check it as well through I can check it through localhost. Okay, this is just my simple web page stating which machine is this, /CentOS -5.4-x_86 x86 or 64. Okay, great. So this is responding on localhost. Is it responding on 192.168.122.1, which is the network interface to my virtual switch? Okay, this is not responding because that virtual interface is not yet up. Xen services stopped. Let me show you here. Service, service, not service, ifconfig. See, it's got only Ethernet 0, which is this IP. It has got this additional IP for some reason. I'll explain that later. It has nothing to do with this training. Actually, I set up a test server here, and I was experimenting with DNAT, so that's why I added this. So as you can see, 192.168.122 interface is not yet up. So to make it up, I have to start the Xen service and libvirt service, and then I will be able to access this as well. It's important to be able to access this because when you'll be installing your virtual machine, you'll be required to provide a URL from where the installation files of your Linux distribution can be obtained. And if this does not work, then those machines will not be able to install. I'll show this all to you in a moment. Okay, so ISO is covered. Okay, that's all for now. You can also use you can explode this tree and export it through HTTP, which is my favorite method, and also NFS or FTP. All three methods are supported. Okay, this is still loading, so I'll just stop it, and this page has also finished loading. So let's see what is the latest versions of Xen right now. Oh, okay. Product release. Oh, great. Xen Hypervisor 4 is out already. Wow, okay. Okay, fine. This is some community member, very good. Okay, so Xen 4 is out and we've got only Xen 3.0. I'm not going to cover Xen's installation from source code at the moment. I'll just go through whatever is available to us as a default. Alright, so let's close this or minimize this window, open this playground, and let's start. Okay, we were talking about disk space here on this storage machine. It has got huge amount of space here on slash data, but only got very few small 6 GB free space left on root. Okay, and I need to delete this stupid rack node as well, so let's go to various lib XEN images list, and I'll just remove rack1.image. This is the disk file, and if you want to make sure, you can just -lh. This is rack1.image. 3 GB is this is probably the root file system. This is one of the virtual servers I created and experimented with. This is just an additional disk which I was experimenting with, added to some virtual machine, I don't remember exactly. Probably rack1. Okay, so I'm going to remove rack1.image to free up at least 3 GB of space. Okay, so this was this location. Remember this? XEN stores disk files of virtual machines here. And let's show you where the config files of virtual machines are stored. etc XEN yeah, list. Okay, here's rack1 and here's vserver. Both are virtual machines config files, and I'll show you how a config file looks like. Let's rack1. Okay, so name of the machine, the UUID of the machine automatically generated by XEN, max memory, minimum memory, how many CPUs it is assigned, what is the bootloader, power on, power off, virtual frame buffer, that is the VGA, and disk. Okay, this is the disk images, rack1.image. so this is we've already deleted, and it doesn't have any other disk file mentioned here. And this is the virtual interface, network interface. This is the MAC address automatically assigned by XEN, and this is which switch is it connected to. Okay, this is important. Is it connected to virtual bridge 0 or XEN bridge 0? So this one is shown here as connected to virtual bridge 0, and that's all in this config file. We're not interested in this, so let's delete rack1 config file as well. Delete. It's just, as you might have guessed by now, it's very small. It's 363 bytes only. So remove rack1. Okay, and edit vserver. And I'll show you here that it has two disks, vserver.image and disk2.image. This is probably an experimental disk, but I don't want to delete it right now because I want to show you proper procedure which you should follow, because if you follow incorrect procedure, you'll probably mess up with one of your production servers sometime. So we'll follow a proper procedure, and since the video is first to show you how to create it, so I'll not go into detail of deleting things. Well, let's clear up, and let's go out of this directory as well. Clear up. Just want to start fresh. Alright, remember XEN service was stopped on this one, so service XEN start. And service lib virtual d start. Oops, start. Okay, and check config -- level 35 XEN d on and lib virtual d on. All right, great. We better create these virtual machines in another video segment. so that it's easier for people to um, plan their study material. So I'll stop this video here and immediately I'll start a new one.